Hello, everyone. My name is Renjie Liu, and I'm currently a big data engineer focusing on optimizing Spark, and I'm also the co-author of iceberg-rust, and I'm glad today here to talk about iceberg-rust. Okay, so let's get started. So today, we will first talk about why Rust for data infra, and then I will introduce modern data stack in Rust. Then I will introduce Iceberg Rust and talk about the roadmap of Iceberg Rust. So why Rust for data infra? So first, what's Rust? Rust is a programming language, as its official set says. It's a programming language enable people to build reliable and efficient software. So the first reason I think Rust is great for data infra is that it has excellent performance, comparable even with C and C++. This allows us to write highly efficient data processing systems where even milliseconds counts. The second point is uh, about Rust's great cargo ecosystem and tooling. Cargo in Rust is not only a build tool, but also a packaging manager. Also, Rust comes with a centralized third-party uh, management service. No, in Rust project, you just need line of code to add a dependency to uh, one line of code to add a dependency to another library. That's quite convenient for users. Cargo will do the rest for you, the downloading and the compiling and the version resolution things for you. The third thing about Rust is that Rust has a unique ownership model and a borrow checker. This helps us to avoid common, common memory bugs, such as null pointer and buffer overflow, without relying on a garbage collector. And the last point is that Rust is a language with modern language features. It comes with async await. It comes with pattern matching, iterator, and closure. Rust closure is quite safe due to its unique due to its unique ownership model and borrow checker. Rust has already been used in real world Rust has been used by many successful projects and successful companies. For example, Rust has been accepted as the second programming language as in Linux kernel. Also, giants like Google have used Rust to improve Android's performance and security. There are many other cases, and just this is just an incomplete list. So let's come to uh, data infra. Data infra. Uh, Previously, open source data infras was mostly writing in Java or C++. There were many successful projects. For example, the Hadoop ecosystem, right? Hadoop file system, the HBase, Spark, Flink, ClickHouse. But recently, there's a huge momentum in uh, reinventing reinventing data infra using Rust. In fact, This has covered almost all aspects of data infra. For example, for streaming processing, we have Arroyo. Uh, for Arroyo, Materialize, and Fluio. For example, for data science, we have Daft, we have Polars, and LastDB. And for analytics, there are uh, Data Fusion, ParallelDB, and DataBand. And for search engine, there are mainly search, QuickWit, Tantivity, and OpenObserve. And for online transaction processing, we have NeonDB and TinyDB. So you can see Rust, data infra in Rust has almost covered all aspects of data stack. So what's so let's come to iceberg-rust. Iceberg-rust is a Rust native implementation of the Apache Iceberg. As you know, Iceberg Iceberg is a spec, right? So we can, in theory, we can implement it in different languages. Uh, before this project, before this project, there were already, you know, uh, there were already several community projects trying to, build a Rust implementation of Apache Iceberg. For example, the Ice Lake community and the Jenko, right? So the authors of this community had a discussion in Iceberg community Slack, uh, and we decided to uh, work together to build a project so that efforts will not be wasted on duplicated work. After this project is created, the community uh, grows quite fast. Now we have 400 stars on GitHub, and we have more than 30 contributors around the world. Okay, so let's come to the roadmap and the status of Iceberg Rust. First, I want to clarify that this roadmap is somehow is my personal idea. It may be changed after uh, community discussion in future. But currently this roadmap is a personal idea in my mind. Okay, so for the the first released version, the 0.2 version, we landed support for metadata. So we finished deserialization of table metadata and manifest, and we also added support for file IO. In the current version and in the current version, in the 0.3 version, uh, the community are focusing on read support from Iceberg table. This includes uh, task planning, filter support. For example, filter push down to pruning partition, pruning manifest, pruning data files. Uh, in the next version, we plan to integrate with more query engines. So, for example, Data Fusion, for example, Polars, for example, Adapt. So, uh, the ecosystem, so the users can read Iceberg tables using a high level language such as Data Frame API or SQL. And in the next version, 0.5 version, uh, we plan to add support for writing to Iceberg tables. It will comes with primitives, both low level and high level APIs for writing data to tables. And in the 0.6 release, we plan to focus on transaction API so that users of this library can uh, can uh, so that we can provide more advanced features to users. For example, the schema evolution, the partition evolution. Mm. In the next release, where the community plans to add support, add bindings for more different languages. For example, Python bindings, C bindings, and even WebAssembly bindings, so that more ecosystems can benefit from this project. And in future, after after we reach feature parity, we complement all these basic things, and even and we reach feature parity with Java or Python library. We will plan to provide more advanced features such as writing or updating S tables using high-level APIs such as SQL or data frames, and also integrate with distributed query engines. We can have provide uh, table maintenance tasks such as compaction or clustering. Iceberg-rust is built using a layered architecture. In the uh, lowest part is file. We provide file abstraction uh, similar to uh, similar to Java library, but we didn't reinvent the wheels. Currently, the file is powered by Apache OpenDAL. This is a great library. Uh, Apache OpenDAL. This is a great library provides a uh, united interface and access pattern for all underlying storage, such as Amazon S3, Azure Blob, or Google Cloud Storage, and of course local file systems. And ab above it, we provide different kinds of file format support, such as Parquet and Apache Iceberg. Again, we don't reinvent the wheels. We co-work with Arrow Rust community and uh, Arrow community to provide support for this data transfer formats. On top of this, we provide primitives to primitives to Apache Iceberg, such as table metadata, the expression systems, the view spec, the transactions. And we will also provide both table reader API uh, and we will also provide uh, table reader API and the table writer API for the high level to use for the high level APIs. We use Apache Arrow as you know in-memory exchange format. Again, we are co-working with we utilize the greater ecosystem of Rust. Also, we will provide different kinds of catalogs, such as REST catalog, Hive catalog, SQL catalog, and a Glue catalog. Uh, for table API, we will provide both reader API and writer API. For the reader API, will the library will provide both for these two parts. The library will provide both high-level APIs and low-level APIs. For reader, the library will provide scan task planning and the filter pushdown for partition pruning, manifest pruning, data file pruning, and even Parquet field pushdown. Also, we will load Parquet file into IRO record batch streams. This these APIs can be used both in as low-level APIs in distributed or parallel query engines, so that they can distribute the scanning the whole table into different tasks. Also, we'll provide high-level APIs to uh, load the table as load the table as uh, load table as error recorded by the streams. But only requires users to provide projections and uh, provide projections and filters. The high-level API will benefit users, writing standalone applications without relying on a distributed query engine. For the writer API, the library will include, file appender to append the data to different data formats, for example, PAPI, IBRO, and also will have different writers. For example, data file writers to append the data and position delete and equation delete writers. Distributed engines can use these APIs as low-level primitives to uh, writing to write data to into Iceberg table. Also, we plan to provide a high-level APIs which accepts a stream of error record batches to append the data directly to Iceberg tables without relying on those engines. Also, uh, although I myself is a big fan of Rust, but there are already many popular and successful uh, data, data products writing in other languages uh, to allow to allow as more ecosystems to benefit from this project. The community has plans to provide different language banding. For example, with the Python bandings, uh, the the most popular with Python bandings, Python users, so pandas users and can use data frame APIs to seamlessly analyze Iceberg tables, and Ray users can also Ray, the distributed computer engine, can use these bandings to seamlessly manipulate Iceberg tables or read from Iceberg tables. Also, the community has planned to provide C banding so that DuckDB user or ClearHouse users can seamlessly um, uh, analyze Iceberg tables while enjoying uh, the great performance provided by these systems. Another cool feature is that the community has planned to support WebAssembly bandings. This is made quite easy because made easy by Rust compiler because Rust compiler can emit can compile Rust code directly to can use WebAssembly as a compiling target. So this will be quite after this will be quite cool. So you can analyze access Iceberg tables in a browser directly without installing any software. Right, that would be super cool, right? Okay, that's all. Thank you.
All right. Well, there is a couple folks. Jan is actually on the chat now, applauding. Jan also is as heavily involved as as Renji had mentioned in the setting up Rust. Okay, let's go through some of the questions. And I actually have a couple of my own, but probably will end up getting asked by the audience anyways. So Pu Chang asks, are there any unique advantages from Rust from a from data infrastructure specifically? I think this is kind of a general question too of like, why is Rust becoming so popular at this point in time? And is there, how much value does it give, as opposed to maybe like Python over C++ and this kind of thing?
Okay, so at first I want to say that I don't mean to raise a wall about
No.
language. But what I say are just my own ideas and my own preference. So I don't mean to raise a wall. Okay, so why I think Rust is great for data infra. I think um I have I've listed the points in the slides, but if you want me to say it in one sentence, is that it's as fast as C or C++, and easy to write and maintain as Java.
Yep.
Yeah, I have long experience, in Java or in C++. So when I meet Rust, I just feel this is the it combines the advantages of these two both languages. Yeah, it has great tooling, great easy to maintain syntax. Yeah, and then
Yep.
quite efficient. Yeah.
Yeah. So I agree with this sentiment. I was also kind of like, well, why is there another one kind of coming in? And there's long been the kind of Java versus C++ wars in terms of like, back end type technologies. One has, generally better measurable performance because you can specify a lot of memory and then and a lot more control over that, but has a lot more areas that you as a developer can create something that is difficult for others to read or understand or maintain, even yourself in the future. And then you have Java, which, has a lot more object-oriented focus that makes it easier in a community sense to develop on, right? And think through these abstractions more than thinking through computer memory and all these other kind of like, things that are easy for just mere mortal humans to forget. So, C++ has always been kind of touted as generally faster if you write things right, if you do things right, but harder to, work across a community. Whereas Java has the community aspect down, but then there's always these concerns around garbage collection and memory management and things that weren't quite working. And so Rust seems to be trying to fit answer all of those kind of issues as best they can, somewhere in the middle, right? Kind of doing various trade-offs where it is a little more readable, maybe not quite as readable, maybe not quite as type safe and all these other kind of things that come in with Java. But at the same time, you still get a lot of these speed ups and memory efficiencies that you don't necessarily get with Java. And so the ecosystem is also very healthy. It's also not, it's owned by a very profound foundation. So I think there's a lot of momentum going towards Rust. Is it a fad? Is it something that's not going to be around forever? We'll have, that's just something that we have to see, and that's always the nature of this thing. But I do think that those are bigger things than just thinking about this purely as Rust for data infra, Rust for this, Rust for that. I think the language itself has a lot of value, and is definitely catching on in terms of adoption. And you'll see a very common thing of, replacing the C++ underpinnings of that are difficult to maintain of a project that has the Python interface to moving that over to Rust. And that's definitely kind of the trajectory that we seem to be on. So hopefully that provides more nuance so that people don't feel like their language is getting attacked. Do we have some benchmarks between read using Rust and Java vectorized read or VLOX, etc.?
The Rust reader is not it's just landed recently, so there's no benchmark against Java vectorized reader. But in my previous work, I my previous work I used to isolate another the library before iceberg-rust we used in our project. We mainly use it to write ingest data, streaming data into iceberg, and we see compared with the first version we use Rust and GNI to write the uh, Java writer, and the second way is use isolate the pure Rust writer, and we see two times performance improvement in writing, but for reading we currently don't have official benchmark. Yeah,
Awesome.
and
And
for
and
vlogs,
Jan, oh, I was going to say Jan provided a PDF here in the chat. If anybody wants to check that out. Again, I trust Jan's judgment in sharing information here because he's done a lot of the upfront looking and stuff. Okay, yeah. So this is Velox, looking at Velox execution engine. And that's within the Velox paper. Yeah. So go ahead with what you were going to say about Velox, Renji.
yeah, I for vlogs, I didn't see. I'm not that familiar with vlogs, so I don't have information about that.
Fair enough. Well, Jan, if you have any other information that you'd want to share that maybe you possibly understand about that, feel free to share that in the chat, and then that can hopefully give anybody else context. If not, I think that more and more as interest grows around these types of like understanding performance implications of choosing, Rust versus the Velox framework in C++ versus, standard C++ type frameworks and things like that. I think that's stuff that we'll come to see, but it's, as with anything, even when you look at Java versus C++, despite there being more of a consistency that people expect that Java won't perform as well, it always depends on the use cases, how you've set things up, how you optimize your memory, and all of these factors. And so it is a really apples to oranges kind of comparison sometimes when you look at these things. But in general, in terms of how people will, the developer experience, the people that will use this, that's going to always depend. And so one particular benchmark isn't going to necessarily, it will shine better light on one type of methodology versus the other in general. Okay. Let's see. So last question that we've gotten from Tushar: how can we better improve the developer experience on Rust Iceberg repo? And maybe Renji, I think another kind of follow on to that is like, is there anything that is, I think the common, we're early in the days of iceberg-rust at this point, but what's the most common issue that people have with what is out there or issues that they're facing? And I think this is also, to me, I'd like to help build out more documentation for a better understanding. But so I'm actually curious to know the answer that you have for this.
If, uh, uh,
Improving the developer. So what kind of ways can we improve developer experience as we slowly build out the kind of facilities around iceberg-rust and getting people onboarded into what's there?
I think I think we should have more. I think one important thing to have more contributors to involving is we open issues, we split issues into smaller issues so that uh, contributors can pick on easy ones and this one by one, and we need a more clear roadmap for the library. Uh, yeah, other parts uh, I um, I have no idea what other parts. Maybe we can improve it with
we can discuss it when the computer contributor have problems. We can discuss it in GitHub issues or in the Slack channel, so we can improve it step by step. Yeah.
Okay. Yeah, and I think that in general, trying to keep in the larger conversation where we're at with the roadmaps and things like that, communicating that better will give people a bit of an understanding of like how they can use Rust and test Rust. But it sounds like from what you're saying, Renji, like there's a lot of work to be done, and more people would be better. I also hear simultaneously in the chat here with Matthew Fournier, I keep trying to hit, to basically contribute, and I'll work on something one day and start understanding it, and then the next day, it'll already be tackled by somebody, and so it's moving really fast, and I think that's a good thing. But and then further down, people were, yeah, it is a good thing. But I do think that it would be valuable to maybe, especially from the documentation perspective, provide a very clear way to, if you're going to contribute, make sure that like you get assigned, and make sure that you talk to these key people, Renji, Fako, and anybody else who's have and Jan, to anybody else who's really kind of leading a lot of the effort here, to get more involved and to try to understand, it's really important to have conversations with experts like Renji, to get more of a understanding of the roadmap and where your talents might best be used, in terms of focusing on different areas. So that's definitely something I will happily be working with folks like Renji moving forward as well. So I think that's hopefully an additional part of the answer, is to make sure that it's very clear to anybody who wants to contribute, steps to take to make sure that you don't lose your spot in line to work on a PR, and similarly, you don't work on something that maybe is out of the context or vein of the roadmap. Can you share the Rust distributed engines integrated with PyRust? Came a bit later. Sorry if this is covered already. So yeah, this is from Yufei. Do we have any Rust distributed engines that we integrate with yet?
Yeah, there are several distributed query engine writing in Rust, but we have not started to integrate with them yet. But it's I think it's a future. We need. There are many. We can list them. Say Deadpan, Ballista, is Apache Ballista. It's built on Diffusion and Deadpan. It's also a Rust query engine and Arroyo, and Dove. Dove is in fact it provides a Python API, but it's in fact writing in Rust. Yeah.
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 And I think actually that's going to be a really interesting thing, is we're hopefully going to start seeing a lot of the code that currently exists in the Python side, right, in the Iceberg side, much like we've seen a lot of the industry start moving towards, having a Rust methodology or implementation, and having a Python interface. Hopefully the Iceberg integration starts just depending on the Rust integration, and that becomes a single location where we can actually maintain one set of protocols or libraries on top of the Iceberg spec, so that when you fix something in Rust, you're actually fixing it in both the Iceberg and the Rust libraries there. And so what's also interesting is, like, if you look at certain things that we require today, like we may need to actually have a way to do reads and writes of Parquet files or something like that directly. I think today we currently use Pyaro to do that, but to have a native way to do that, and actually I think Rust has a way to do that currently with Parquet, And so that becomes interesting, is like, well, if we do that, is that one kind of area where we could directly write and utilize like a Parquet writer versus having to depend on a third party to handle that particular area of the code, right? I don't know. That's I think another cool aspect. Are there other, I guess I'll come in with a question. Are there other advantages and like kind of things that we've pointed out in terms of why we should be doing this, and in terms of like migrating some of the Python backend to Rust? And a second question would be like, when do you think this would be taking place based on current conversations? It could be a guess if you don't know for sure.
We had I think I have to say that the Python integration, Iceberg integration is in early discussion. So maybe 1 year later.
Yeah,
it's quite early. Yeah.
So it's not something we should expect to see in like the coming like months or quarters or anything like that, unless this becomes like a heavy topic of the community or something.
I'm afraid it's not coming in short.
Anytime. Okay, great. And then are there other advantages other than just like centralizing it to a single library, or a majority of the implementation details to the Rust library, and not having to duplicate that management in the Python side? What other kind of advantages do you see in moving things over to Rust, from maybe more of a performance or integration capabilities with, say, like all of these query engines that Yufei was asking about? Is there better? Does that immediately give us like advantages in terms of integration with Rust based query engines?
Yeah. Not only with a Rust-based library, not only we can not only handle the read-write Pocket files in a native way, but also all the planning phase can also utilize Rust. Yeah, and the other benefits. I can't come up with.
Yeah, that's fine. I mean, I think a lot of people have asked questions around like the performance thing, so I wasn't sure if like having a native kind of API helps us in terms of expressing the types of native expressions that might happen in Rust a little easier than you would in Python or C++ or something like that. Like, obviously we said maintenance would be something that is better performance with easier like somewhere between better performance and easier maintenance. But I guess it kind of comes into the question of, is there better ways to express kind of direct parallels to things happening in, let's say, I don't know, Daft or DataBend or any of those that have a Rust underbelly? Is that more easily expressed or understood when we have a Rust to Rust integration?
Yeah, I think I think the code will be easier to maintain. In my experience, we tried to in my early work, in my last job, we tried to write Rust integration with a streaming engine by wrapping a Java by wrapping Java API, but we find it difficult to maintain, just because there are many we needed to maintain both structs in Rust side and Java side, and the conversion using JNI is quite a bit painful. So pure Rust to Rust conversion would be easier to maintain, much easier and more efficient. Yeah.
Okay. Yeah, that's good. So I do think, that's probably where we're headed long term. When it happens, it seems like that's still up in the air. If you're interested in getting involved, I highly recommend finding Renji Faco or Jan on either Slack or bringing up ideas that you have on the message list, on the message boards, through email and things like that. You can find all of that information on the Iceberg website under the community tab. Yeah, and so I think that's, if you're interested in getting involved in that way, definitely check that out. I'm trying to think if so definitely we'll probably, Renji, this is good prompting for us that I'll happily start trying to go through maybe having a contributor guide, a better contributor guide that kind of clarifies, different aspects to be considerate of. Like if you're interested in doing something, you should raise your hand, make sure it's known that people that you're working on something, and then kind of making sure the communication's there. But also, having upfront communication with you and Jan and Faco early on is probably also like really good practices to follow. Showing designs and things like that, bringing that to the Iceberg community sync to get a larger audience to see it and critique it. Always also a really good idea. Anything else that you're excited about or you'd like to share regarding like the trajectory, how, this will improve adoption or anything like that in terms of Rust? Like what gets you the most excited about this implementation around Iceberg?
I'm in fact, I'm the most excited part is that iceberg-rust will lay a foundation. I believe lakehouse architecture is the future of data architecture, and iceberg-rust will lay a solid foundation for lakehouse in Rust. There are already many successful many engines writing in Rust, as I have listed, but the table format is missing in Rust world. So
Yeah.
I think when iceberg-rust gets ready, the whole data infra, we one day we no longer need a Spark or Flink. We have Rust alternatives for the data processing world. Yeah.
Awesome. Yeah, that's a great answer. I totally agree with you. I think also another thing that gets me excited that already kind of exists today with the Python integration, but it's simply for me, I think from developer experience, and so pedagogically, you need a way to showcase what a table format is, because people are still rather confused by even the notion of a table format versus like file formats. And so Rust, has the PyO3 integration, and you can actually embed that into Python environments. And what's cool is like you have things like Pyodide or Rust actually running on things like Wasm. And that enables us to actually, get to a point at some point soon, hopefully, that we can embed a lot of environments to run on WebAssembly within documentation, within blogs, that will do a much easier and better job rather than having to rely always on like Docker being installed or all these other things. You simply need a web browser and then enough, I guess, memory and things like that to run. But you will be able to basically run and understand and get in touch much quicker with the concepts behind Iceberg. And I think that's going to do a lot for adoption. It's done a lot for DuckDB and all these other engines, as well as Polars, to be able to be adopted much quicker. And I think that, it's long overdue that something like Iceberg has that adoption. So I think that Melissa coming on is indicating that we're hitting time. So thank you all for joining. Thanks, Renji, for this, for everything you do around Rust. And thanks so much for this presentation, kind of keeping us up to date on where we're at here. Any parting words or anything you want to say to the community?
I see a lot more and more people getting involved in community and contributing to this project. And I want to thank everyone for the contribution.
Yeah, and I think the future of the future, we have a bright future for
Absolutely.
lake house in Rust.
All right. Agreed. Renji, thanks for joining us so late in Shanghai, and go get some sleep. And thank you all. We'll look forward to a bright and happy future with Iceberg Rust with you at the leadership of it. Thanks a lot.